Good morning, or it might be evening for you. I'm recording in the morning. Today what we're going to do is we're going to do a bit of review for our next unit. Our unit is, now this will go blurry for a second. I just want to make sure it's as clear as possible. But we will be doing some review to help you in this unit, Unit 2, Quadratic Functions and Equations. Okay, so what we're going to review is equations of lines, and we're going to review a little bit of the quadratic equation in a vertex form. If you recall, that looks like this. Okay, so we're going to do a little bit work on linear systems by graphing linear lines, and solving not only by graphing but by elimination and and just finding the equation of a line. So let's do that just very quickly. Example 1 is determine the equation of the line in this form, y equals mx plus b. You know m is the slope and b is your y-intercept. Okay, to determine the equation of a line, to find the equation of a line, we need two things. We need one, a slope, and we need two, a point. So we have a point, we have 2 points, we only need one, but we need to find the slope of a line, and that's going to be x2 minus x1 all over what? Oh, sorry, we have to do the difference in the y values over and divide it by the difference in the x values. I must have had a senior moment there, so let me just fix that up right now. So m equals y2 minus y1 over x2 minus x1. Usually you put one equation per line, but I'm going to be running out of space, so I'm just going to go equals 3 minus 2 over 6 minus 1 is 1 over 5, right? 3 minus 2, which is 1, 6 minus 1 is 5. So our slope is 1 over 5. Now that we have our slope and a point, so we're using point-slope form. Oh, my staple's getting in the way. Form. We have y minus y1 equals m times x minus x1. So I'm going to use the point with smaller values. No sense working with bigger numbers if I don't have to. Equals 1 over 5 times x minus 1. So we have y, I'm going to add 2 to both sides, 1 over 5x minus 1 over 5 plus 2. Y is equal to 1 over 5x. Well, we have to get a common denominator, so this is 2 is equivalent to 10 over 5. 10 over 5 minus 1 is 9 over 5. So there's the answer to that question. The beauty of a linear equation in this form is we know the slope is 1 over 5, so every 5 units it goes to the right, it goes up 1. And the y-intercept, where it crosses the y-axis, is 9 over 5. Okay, solve the following system of equations graphically. Graph the equations using the x and y intercept, and then we're going to check the solution. So be careful to follow the instructions carefully. So starting with the line y equals x plus 3, let's find the x-intercept and the y-intercept. So you know the x-intercept occurs when y equals 0. So subbing in 0 for y, we get 0 equals x plus 3, or x equals minus 3. So our x-intercept is minus 3. Our y-intercept occurs when x equals 0. So now we sub it in y equals 0 plus 3 or y equals 3. So our y-intercept is 3. We can graph that line using the 2 points. We only need 2 points to graph a line. Don't forget there should be arrows on your axes to indicate they go on for forever and ever and ever, or for infinity. The x-intercept is negative 3. There's our negative 3. Y-intercept is 3. So we'll plot that there. And just as carefully as we can graph this point. This line, sorry. Uh-oh. I don't think my pen quite made it. I just want maybe another point to help me out there. There we go. There we go. Okay. So this is the line y equals x plus 3. You should label your graphs. You want to communicate clearly. Okay. Let's look at this one. Where again the x-intercept occurs when y equals 0, right, just like up here. So 0 equals 1 minus x, negative 1 equals negative x, or x equals 1. So our x-intercept is 1. Now our y-intercept is, we let x equals 0. See here, we let y equals 0. Okay, so we let x equals 0, y equals 1 minus 0, y equals 1. So now we have an x-intercept of 1 and a y-intercept of 1. So there's my y-intercept of 1, there's my x-intercept of 1, and just we're going to draw that as carefully as we can so that we can try to get an accurate answer. So the trouble with graphing is we're eyeballing things. So notice it looks like the solution is negative 1, 2. Okay, right there. That's our point of intersection. So this is y equals 1 minus x, again label, and this is our point of intersection. So the question said, solve the following system of equations. Our answer appears to be negative 1, 2 as far as we can accurately read the graph. Okay, how can we check this answer? Well, let's sub it into the, let's sub these points into the lines. We'll calculate the left side of the equation and the right side, and just using the point negative 1 and 2 to check, to make sure this is our solution. We want to see that negative 1 and 2 satisfies both this equation and that equation. If it does, we know we have our solution. So we'll check in y equals x plus 3. So we know left side equals y, and y equals 2 according to our solution. Right side of our equation is x plus 3, and we'll sub in negative 1 plus 3. That equals 2. Oh, so left side equals right side. So far so good. We know it satisfies this line. Let's see if it satisfies this line. So we will check in y equals 1 minus x. Okay, left side equals y, right? Left side equals y, and that equals 2. Right side equals 2. Right side equals 1 minus x, and that equals 1 minus a negative 1, and you know that that's equivalent to 1 plus 1, and that equals 2. So left side equals right side. Now we can say that it checked in both equations. Now we can be absolutely 100% sure that therefore negative 1 comma 2 is the solution. Okay? Moving right along here, solving, linear systems by elimination. Let's label 1, 2. Use the method of elimination to find the intersection of the following lines. Okay, well, if you recall, I'm going to be subtracting, but I need to bring this up to a 2x, so when I subtract, the x's fall out. So I'm going to go 2 times 1 is going to be 2x plus 4y equals negative 6, and equation number 2 is 2x plus 3y equals negative 4. So 2 times 1 is minus 2, right? 2 times 1 minus 2 is going to be y equals, right? 2x minus 2 is 0, 4y minus 3y is y, negative 6 minus a negative 4 is negative 6 plus 4, which is negative 2. So now we can sub y equals negative 2 into 1. So we go x plus 2 times negative 2 is equal to negative 3. I subbed it in this one. X plus 2 times negative 2. I got y to be negative 2, so I sub it in to calculate x, right? And that equals negative 3. So x plus 4 equals, oh sorry, a positive times a negative is negative, equals negative 3, x equals 1. So now you have to write your conclusion. Therefore, the point of intersection is 1 comma negative 2. And you could check your work as before, just to double check your work just to make sure it's the right answer. Okay. Let's review a little bit about vertex form of a quadratic equation. So it says complete the table. As you recall, the vertex is h comma k. So in this case it's going to be 1 comma 7, right? Because that's x minus the h. So minus a negative 1 is positive 1. So here the axis of symmetry is x equals h, or x equals 1. Now when a is greater than 0, you know it opens up. When a is less than 0, it opens down. And so it's a negative value. A is less than 0, so we know it's down. It opens down. And y-intercept occurs when x equals 0. So let's calculate our y-intercept. Y equals minus 2 times 0, negative 1 squared plus 7. Y equals negative 2 times 1 plus 7. So y equals 5. Our so let's see what we can do to graph this parabola. I'm just getting my ruler ready. And remember, there should be arrows there to indicate it goes on forever and ever. Those axes go on forever and ever. So our y-intercept is 1, 2, 3, 4, 5. Just assume each square equals 1. Each square has a unit value, 1, 2, 3, 4, 5. Our vertex is 1, 7, so that's going to be, there's our 1, right? 1, 2, 3, 4, 5, 6, 7. There's 7. We need another point at least to get the other branch of this parabola. So we're going to reflect it in our axis of symmetry. There we go. So this is x equals 1, right? Here all the x values are 1 and the y values are right there. So we can reflect the y-intercept in the axis of symmetry as such, because we know if there's a point 1 over to the left, we know there's 1 point over to the right, because we know the parabola is symmetrical about the axis of symmetry. So there's our graph right there. Good. That's about, there's I gave you the equation of the axis of symmetry. the equation of this parabola is y equals negative 2x minus 1 squared plus 7. Okay, we have one more item to do. We want to change an equation that is in standard form. Just don't let that symbol fool you. It's ax to the exponent 2 plus bx plus c, and we want to convert it to vertex form. So this is standard form, and this is vertex form. So we want to rewrite the equation in vertex form. So if you recall, what we have to do here is have and square the coefficient of the linear term. The linear term is here. This is the quadratic term, the linear term, the constant term. So let me write my equation here. X squared plus 6x plus 8. So what we're trying to do is convert this to a perfect trinomial square. So let's do that. We're going to have the coefficient of the linear term, which is 6, and square it. So this is going to be 3 squared equals 9. So we're going to add 9 and subtract 9, and we can't forget the plus 8. By adding and subtracting, we're adding 0, so in effect we're not changing we're changing the look of the equation, but we're not changing, the x and y values. And we're not changing the shape of this graph. The shape of this graph will be equal to the shape of this graph because we're just adding 0. So here we have our perfect square trinomial, so that is easy to factor. So y equals, if this is a perfect square trinomial, because we did this step, we know this is a perfect square trinomial. So you take the square root of the first term, the square root of the last term, and since that's a plus, that's a plus. Minus 1. There's the answer. There's our answer. This is vertex form. So there's vertex form. So remember, the beauty of it is we can pick off our vertex, which is -3, -1. We can pick off our axis of symmetry, which x equals -3. It's just the beauty, but that's our answer right there. Okay. If you have any questions, you can ask me during class or during the second half of lunch every day. Take care. Have a good one. Do your homework. Remember, repetition is the law of learning. And check your answers at the back of every question you do, check your answers at the back of your textbook. Have a great day. Bye-bye.